Welcome to Developers Meeting on Sunday, the 28th of May. And I give the word to Ido to kick us off. Ido, please.
Yeah. Hi, everyone. Yeah, let's kickstart. David, you want to go?
Sure, yeah. So I don't have a great deal, but I can maybe share my screen and show you a few things. Just let me know if you can't see that.
Yeah, if you can make the font a bit bigger.
Sure.
Yeah, perfect.
Cool. Perfect.
So this week, Fabio and I were working on just refining the app he's developed a little bit, just on the interface, just so things look a bit nicer to look at. And so I'll open that up and show that first, and then I'll show you a few other things that we've been doing as well with the algorithms. Yeah, so there's been a kind of few refinements to the interface. I guess for the people that have just joined us today and are new, this is just like a little app that's been developed for gathering and data from the camera that we're using, and also for controlling the camera parameters and logging data and stuff like that. So what you see here is the view of that camera, so QHY camera. But the interface refinements, we've just got just a bit of a nicer layout, really. Just have like pop-ups if you enable things, so enable logging. It kind of pops up and tells you what's enabled and what's not. So that's just a minor thing. I know Fabio was working on something to do with how the frames are pulled. The FPS readout at the top right here was incorrect, so he was doing something with that this week. I don't know if he's managed to integrate that fix yet, but I know he's got something in mind for that. So as you saw with the app there, you can log data. So I left the camera running for 4 days, logged a load of data on, so we can try and understand how the auto algorithms work for exposure and white balance, and recorded some other things.
Could you maximize that view, please?
Yeah.
Oh, yeah.
Is that any better?
Great.
Yeah, so you can see over 4 days, first, about three and a bit days. First couple of days were very similar weather conditions. It was sunny, which is pretty rare in Scotland, I have to say, but first couple of days. So I've got an east-facing window where the camera is, so you see quite a lot of brightness fluctuations in the morning, in particular, because of the sun that's coming and going behind the clouds. And then in the afternoon, it kind of steadies out. So this top plot here is showing the target we're aiming for, target brightness, and then the actual brightness at the time for the exposure setting that we're using. So what we want to see here is the brightness tracking with the target. And then it switches over at night time, and then it switches back in the morning again. So I mean, if you look at exposure, I mean, it's kind of, it was a bit erratic around this first day, and I changed a few things with the algorithm to try and deal with that. The exposure was kind of moving around quite a lot. So and you could actually, if you were watching the camera, the view of the camera, you could actually see it. And I guess a good kind of thing for an auto exposure algorithm is that you don't notice it at all. You know, so it's kind of it's not perceptible. It's changes. So try to adjust the algorithm and managed to get it a little bit better the next day. So there's still some refinements that need to be made with this, and the more the developers that get the camera up and running and record this data, the more we'll be able to improve it, I think.
But may I ask a question, David?
Well, go ahead. Yeah.
So your idea is to smoothen that out, so that you have less erratic changes in exposure and gain.
Yeah. I guess trying to make it imperceptible to us, but also to a background subtractor, that comes after this. If you've got a sudden change in gain or exposure, then I guess it could cause issues with the background subtraction and other things, probably. So I'm just trying to make it nice and smooth. So implemented like a non-linear change. So when you've got shorter exposures, it does smaller steps, and then at longer exposures, it does slightly larger steps. And I think that's helped a great deal. One thing that you raised, Richard, in the chat as well is these notches. So these notches are the transitions, happen around the transitions that occur between like day and night mode. So if it switches to night mode, you get a dip in gain occurring. And it looks quite sudden, but actually this is over, if I can zoom in a bit. It does kind of happen over a few minutes, but I think we can still play with these transitions just to make it a bit smoother.
My question, David, is why does it happen at all? Why especially when you really can see the pattern here, that when it changes from sunset to night, that there is this little jump in the gain.
Yeah, so when it changes to night mode, it drops the target brightness for the frame, and then as a result of that, it lowers the gain down because it's too bright at the time it makes the drop. The gain is too high, so it tries to compensate for that by dropping the gain. There's maybe a cleverer way we can deal with that. We can anticipate, there's going to be a change to a change to night coming, and then therefore we don't need to go any further. We can just switch over to night. I need to think about that a bit more. There's maybe a cleverer way we can do that and avoid these sorts of things.
But exposure is something that you, let's say in the night, you set to a max, because we go with, let's say, 50 milliseconds exposure, so we get 20 frames per second as a FPS. And when I see this graph, it instantly attaches, so it instantly goes to the max level. Is this something that's in the algorithm from there? Yeah, exactly where you are, exactly where the vertical sunset line is.
Yeah, so it kind of ramps up to it because we're losing light in the afternoon, late afternoon, and then around about sunset, it kind of we hit the 50 milliseconds max exposure. And then after we hit that max exposure, we start to ask it to increase gain. The reason why we do it in that order is we want to keep the dynamic range as high as possible. So when we're pumping up the gain, we lose dynamic range. We also draw up the noise as well. So yeah, I mean that looks like a short time, but actually that's quite a long ramp up, and that's not really perceptible if you I've been staring at it too much. I've been watching this running over an afternoon, you know, and into the evening, and it's not really that.
Could you zoom in so that we can see the exposure and gain, so that we can see both graphs?
Yeah, does that look?
More down, more downwards, that we also see gain.
Yeah, if you zoom on one plot, it zooms the other plots as well. So.
Okay.
Yeah.
You can zoom only one plot. Okay. I
Yeah,
see.
Yeah, so exposure hits the limit, so it starts to ramp up gain after that.
And then it decides the gain is too fast ramped up, and then jumps back and then flanks back up.
Yeah.
When this happens.
So that's where the switch occurs.
Yeah.
It's like a transition to night mode. So it readjusts itself, and then starts to get even darker outside. And then...
But wouldn't that speak for that the timing for the target MSW is too late? That it should be earlier, so that the gain that goes up, because the spike at gain, at the gain, that one is exactly when you switch from the target from day to night. That this is the case, just the timing when it is happening. So my question is, when you take the switch from day to night earlier, when it reaches, let's say, when exposure reaches its limit, its max, then the time, then the target MSW shall then be switched. I'm just thinking loud. By this, it could happen that the gain is shifted to the left as well, and maybe it's more flattened out the curve from the gain.
Yeah, it's a good point. Yeah, maybe we get rid of that notch then. Yeah, it's something to try. Actually. Yeah.
May I make a suggestion? What if you were to take an average of all of the pixels' brightness and kind of determine the time of day or brightness and control your values that way, instead of using a timer?
Yeah, there's actually no timer on this. It's
okay.
It's as you described there. It's taken a brightness, but yeah, we take the mean brightness, the mean over the frame, which gives us the brightness. I think is that what you mean? The transition.
Yeah. Mean, average. So in my vernacular, average and mean are the same thing.
Yeah.
So basically, what you do with the evaluation of the MSW is basically the mean average calculation, isn't it?
Yeah, mean sample value, MSV.
Mean sample value,
yeah.
So that's why you see two lines in the first graph. One is the target and one is the actual, the current. And by adjusting exposure and gain, he tries to that the current MSV is matching the target MSW.
That's right. Yeah.
I think it's a timing. It's a timing question.
Yeah. Try your suggestion, Richard, of and see how it goes. I mean, switch to night when we reach max exposure, and then see how things go. We can play around with these parameters. We can change them easily, of course, but I think.
But what we can say, David, is that any change in gain that is such significant as the spike, which on the right flank, actually, the quick fall down, that's certainly something that the BGS does not like.
Yeah. There we go. And going down the other way, we drop gain first and then start dropping exposure. And then there's a switch there, so we get that kind of notch happening again because of the switch. So, yeah. Definitely look at these things.
The less these spikes are visible, the better for the BGS, right?
I think so. Yeah.
Hmm.
Yeah. I mean, you want to try and keep things as smooth as possible and try and get the best image possible as well. So there's metrics we can look at. I mean, I've recorded entropy here, which gives you it's one of the metrics you can use for determining image quality. But there's other ones as well. You can look at gradient across the frame, and that gives you an idea whether it's overexposed or underexposed. So there's stuff we can do with that as well. I think basically we just want to get the most stable algorithms, but also the best image quality from the image possible from cameras. Yeah.
But one thing that's interesting for me, and we discussed it this week, and I just throw it in because it's interesting to see the white balance. White balance, you have red, blue, and green white balance. And what baffled me is the opposite behavior between red and blue. And you said that during. Now, please explain with your own words why you think this is opposite. Why blue and red is opposite.
I'm still learning about this, so I'll probably do a terrible job of explaining it. But yeah, I think what it's down to basically in the morning, outside I've got the sunrise, so there's more reds being picked up by the in the camera, and then in the evening it switches around. I've got less reds, more blues on these days. So the algorithm I'm using is the grey world algorithm. I think it's quite a commonly used one to white balance, but yeah, basically these changes are trying to.
So you mean they are due to this algorithm, this specific algorithm?
Yeah, all of the changes that you see here are down to that grey world algorithm.
Okay.
It's trying to adjust the white balance level so you get a consistent image.
You can use that to make a decision on day mode and night mode.
Oh yeah. So
because it's happening before and after. So when the color shifted to be more red or more blue, then it's morning or night.
I guess it becomes a problem when it's cloudy, but if it's more overcast.
But I think even with cloudy, it should still be like either more red dominant or blue dominant.
You can always check the crossover points.
Yeah. And again, I always look at it as a metric. So those are like white balance should be one of the parameters in the metric for calculating changing day mode. Not the only one. Not the only thing.
Not the only thing. I wouldn't have guessed that.
Yeah.
Okay. Well, there's certainly a lot to learn here.
Yeah, it's a work in progress. So any suggestions at all?
I have a suggestion for the UI.
Sure.
So before you suggest about UI, okay?
Go ahead.
So this is still like experiments, okay? So it's not integrated to AI, which UI, which is OpenMCT, okay? So what I wrote earlier today for David and Don, it's once we integrate it into ROS 2, then all of it, we can push all of this UI into OpenMCT.
Oh, nice.
Okay, and it will be like straightforward because
maybe either we shall explain it. So what you see here, Disto, is a tool to test algorithms and hardware. It's not the final product
of course
with the user interface. It's just an internal use thingy.
Right. My suggestion was only going to be for the graph specifically.
Go ahead. Make it.
A throwback to what you were saying about zooming in on all of them at the same time versus zooming in on one at a time. You could possibly throw in a keyboard modifier, like holding the shift key whenever you drag your selection rectangle over a section, that it only affects that, or if the shift key isn't pressed, then it does all of them, or maybe vice versa.
Oh, thanks. Yeah, I didn't realize that. Yeah.
The question is whether we shall invest so much effort in creating a good usability case here, because it's
Of course.
maybe in 2 weeks we do not use that anymore, because everything is learned from that already. So it could happen that your idea is basically a good idea, absolutely, but it will not go into this product because we leave it in a couple of weeks.
I'll wear my engineering hat, which is the only hat I have, and I will say like this is ready for integration. Okay, so it will be best to work like next on integrating into ROS2.
Yeah.
Because that will allow also to ROS2 will not remove the ability to improve the algorithms. It will actually have better integration with even better tools to help with that. Because it will integrate with the simulation, it will integrate with everything else that we have, including OpenMCT. So from robotic perspective, this is good enough that we can take it, integrate it, and then we can continually improve on it. But because it gets us to the product. If you're continuing improving where you are right now, it's not getting us closer to release the product.
Right.
You're just
right.
you're just improving your app.
I don't mean to detract from the flow of the conversation.
No.
Just a little poke.
No, not at all. It's fine. It's just like it's an open source project, and it's struggle to focus on like a release.
Yeah,
and I'm
focus
trying
on
to
the algorithm.
and I'm trying to help with the team focus on what's next is needed, right? Because we can work on algorithms all day long, but if it's going to be tedious for people to build everything and run all these apps, it's not going to be usable for people that wants to have stations, right? So that's why like the ROS2 integration is very, very important. I'll speak with Fabio about it more, because I think once Fabio gets a hold on it, we will accelerate on that as well.
Mm-hmm.
Okay.
And then Don will do his magic with OpenMCT, as I saw already. So Dan, sorry.
Good question, Ido. You brought it up. What are the next steps that brings us to the product? What steps are needed actually at the moment?
Yes. So okay, let's take a big discussion here, because it takes us also to the database.
Oh yeah.
Decision. So, okay. So we want to have the fisheye camera, being out there and be operational as much as possible. Okay. So I would say that the alpha version, it's not about recording data. It's about making sure the system is running. We detect failures, we fix the failures, and we improve on that. Okay. So have that is very, very have that deployed. It's very, very important. Mm-hmm. Okay? So. What do we need for that? We need basically the Orange Pi 5 with an image that has the SDK for the QHY, has our software. The tracker is fine also to run, and just display a video and everything that we saw now around the background subtraction and all the parameters, just display on OpenMCT. Okay, I'm not even speaking about recording anything right now. Okay, bare minimum. Okay. I think that's like the first step that we want to get to, because then we're going to get much more confidence and much more understanding with how the camera operates. Okay. And we can have like between us some discussion internally how to share that data or stuff like that. But again, I wouldn't say recording is crucial right now. And that gets me to the next step. The next step will be recording is crucial. Okay. Now, it's very important to understand that recording in such system, and I'll explain what such system is in a second. But recording needs to be how will I say that? Needs to be designed in a very specific way. I heard Richard, we spoke about earlier today. I'm not a big fan of a rolling store, okay? Which means that I'm writing all my hard drive, then I'm starting to delete and rewriting and delete and rewriting and all of that. I'm not a big fan of that. It's fine for logs, but when you start discussing raw data, if you first of all, you're not going to have time to go over all the data. It's massive amount of data, and as you know, deleting and writing data to drive, specifically if it's NVMe, you're just causing damage to the hardware. So it's better to write what's important, and that's what I see the storage needs to do. Which means like the storage is kind of observing the system, keeps a large cache, let's say 5 seconds cache, 10 seconds cache, 20 seconds cache. We'll discuss that because again, it's a lot of data. For example, the fisheye camera, 15 seconds data is around 5 gigabytes. Okay, so if you have an event that is 30 seconds, 60 seconds, that's already like 20, 30 gigs, easy. Okay, and those are the important ones that you never want to delete, unless there was a physical delete. When someone said, on Apple MCT, delete this event, right? So I do see like event has what I call like a pre-alarm, like before the tracker detect something. So, for example, if an object flies in the sky, and the moment that object was detected by the tracker, we have 15 seconds prior that of raw data in cache. We start dumping it to disk, and we are starting to dump all the new events until the event is over, tracker stopped recognizing the object or whatever, and then we continue 15 seconds after, okay, what's called post-alarm, and that's called an event, a recorded event, okay? Now, it's very important that we can also start manual recorder, right? Someone says, oh, this is an interesting, the tracker didn't see or whatever, click on a manual recording, start recording whatever, and then stop it, right? This is a very good recorder to start with, okay? Not with a rolling one. A rolling one will not give you the understanding that you need, and it will just destroy hardware, honestly. As for how you record, this comes to the database discussion, right? Now, if you're familiar with databases, right? Databases are usually like CRUD operations, create, read, update, delete. They're not really designed, to hold raw data, specifically not like an image SD5, okay? That's why like database is kind of not geared for raw data image storage, okay? Now, when you choose a database, you need to think about what is it going to be used for. Are you going to have more writes? Are you going to have more reads? Are your queries are going to be complex? Or are they going to be simple? And here, it's kind of straightforward answer for what we have, because we are recording events, which means we are time-based. And if we are time-based, there is databases like Prometheus or whatever that are time series databases. And they are designed to store data like that. All the situational awareness of what we see, from the camera parameters to the tracker outputs and all of that, we can record 24/7, and we will record 24/7. Okay, those are important, right? And they are not that much. There are multiple kilobytes of information. That's fine. Raw data of images will be recorded once an event was created, either a manual event or a detected event or whatever. Okay, and it can be a random event that the system decides, hey, I want to record now for 30 seconds for whatever reason. That's fine also, right?
You were mentioning Prometheus database. So
just an example. Yes.
Okay, it was an example. Okay.
Yeah.
I'm not familiar with Prometheus. Is it something like GraphQL?
No. So GraphQL is a database that is designed for graph, querying a graph. Okay. So which means you have like a node that has children, right?
Mm-hmm.
So it's like a tree, like that you query.
Mm-hmm.
You use that when you want to analyze something.
Mm-hmm.
Okay, but we don't have that problem.
Okay.
Okay. Not on a single station level. Okay.
Yeah.
When you have many stations, right?
Okay.
And you want to, and then you have an anomaly that was detected, right? And now you want to start correlating and say, hey, where did I see similar anomaly in other stations, right? That's a complex query. That's something a graph database can help you with, right?
Okay.
But again, it's not a simple graph database, because here you speak about understanding imagery and understanding like deep situational awareness. So even then, like I will question which database really can do that. It's not straightforward, but this is again really advanced and multiple stations. Okay. Yeah.
If I may,
yeah.
Okay, so I understood GraphQL is something completely different. Can you give me an example of Prometheus? What is the key feature of a Prometheus database? Why Prometheus?
So Prometheus is so Prometheus. I'm just using it because it's like a very common database to use with the visualization part, Grafana. So it's basically record everything based on time, and then allow and you create like a bucket, and in the bucket you provide your matrices, okay, and then it allows you to query based on the time series. So you can what happened in the last hour, what happened in the last 5 minutes,
you can
what
rewind,
happened in the last
play forward, and so forth.
No, not rewind and play forward. Query that.
Yeah, query that in order to be able to. Okay.
Rewind and play forward is different. And if you want to speak about that's very, very different.
Which case it's not the same. Okay.
So I'll explain. When I speak about a recorded playback, I speak about a system that understands, our time, or like the system time, and allows the system time to change. Okay, so when you speak about a rewind, you're starting to change the system time backwards. Okay, And now all the visualization part that you see needs to adjust to that time and query from Prometheus, as an example, that specific time slot, right? So if you're starting to reply, backwards, if you have a video visualizer, then you need to query the raw images, backwards, right? If you have now the background subtraction and entropy graph, you need to query, let's say, Prometheus backwards based on the zoom that you're in, right? And kind of make it like more like it's more of a real-time thing, right? Replay and rewind and forward and whatever.
This
okay.
Time series data.
Excuse me.
I'm sorry.
So the Prometheus is really good for doing dimensional data and for time series data. It's basically imagine each entry as a moment in time, and the overall entry being the footage itself. Whereas where you were talking about GraphQL, graphical query language, as being really useful for being the control system for your various cameras. You could set use that for you could set all your cameras as nodes within that system.
Well, we only have one all sky camera now.
Okay, I'm still trying to catch up with the
the wording.
So you're right. So GraphQL is designed to query usually millions, if not billions, of nodes. Okay.
Right.
That's what it's, and it does that very, very well and very, very fast. Right.
Right. It would be very good for once you have multiple 360 Skycams. It would be really great for
yes,
organizing all of those. Whereas the Prometheus would be really good for processing the data from each camera.
Yes.
Okay. Got it.
Yes. Yes. So Richard, for you to understand better, GraphQL is really good. For example, like Facebook uses it, Twitter uses it. Okay, because the graph of personalization is just like so complex. So they use GraphQL to describe it. For example, in Facebook, you have your wall, right, and then you have your friends. Right, and you have your wall friends, right? So how your wall is being constructed, that's something a GraphQL can do. A GraphQL database. Okay.
So
a Graph database.
Yeah, got it. So you mentioned simulated time, or do I understand this right? That in order to have that feature kind of a playback, so let's say to roll back the timer going back in history means that you on one hand have an actual current time, but you also have a simulated time that you then scroll back. This is you need the simulated time. Is it right that I say that?
I
read this paper and it was talking about it. So it's the same thing that we need to implement.
So ROS2 already has that. Okay. And so there's OpenMCT.
Yeah.
Okay, we just need to use it. Yes.
OpenMCT is already capable of simulating time.
Oh, of course, yeah. Otherwise, they will not be able to analyze any experiment in space. They have to be able to.
Yeah, okay, because everything is on a time delay, right?
No, think about it. Like a mission in space means that they are setting up sensors for a specific, time and coordinates, and then they're recording for several hours or days, right? And then, the investigation happened, which is the big part of a system like that, when they need to go back and look at all the data, right? But bear in mind, when they are doing recording, they have a big storage. We don't have that luxury. right?
Okay.
Yeah. So our and again, they are recording. Technically, we can do the same. It's just going to be like a manual event that we record for several hours, right? And hope that we are not going to fulfill a 2 terabyte or 4 terabyte drive, right? Because the moment we will have like a passive radar, that's going to be a lot of information for like an event.
So, for example, I want to stress this topic just for now, quickly. There is a situation when a station is offline, but still records, let's say, because it works offline. And then it comes back online for whatever reasons.
Yeah.
And then the data shall be uploaded to a central node. But we're not talking about this right now. My question is,
yes,
if a local storage which has a certain amount of storage capacity is full, what then?
So yeah, if the storage is full, right, now you need to delete events that you recorded, right?
Who?
In my world, it's called like I want to get into a system failure that says, hey, disk is full, okay, and then I will have a GitHub issue, which I love, and then I will address it, okay?
How?
Because then it will become important. Until then, I don't care about it, right? No. Again, I'm trying to attack what is most important.
Yeah, absolutely.
Right?
I get it.
Right.
If I need to attack now that the disk is full and we don't even record yet, I'm not optimizing myself for a release.
Okay.
Right. One approach would be to have key moments that could be taggable and move to another storage medium. And,
yeah, you can drag it down.
And then you can have a live feed and remove the first index time slice as it goes.
I can tell you can change the storage, add another one, right? You can swap them. There is a lot of solutions that I want to discuss under the bucket of a GitHub issue says disk fell or disk is full, right? Or whatever, right? I like to have like system failures and address them in issues so we can discuss all of these solutions together. And then, because, disk is full, there are many ways, and we just spoke about like 5 different solutions for it, right? And you're most likely going to have more than one, because we will have, many stations out there. Everyone will treat them differently. Some of them will say, oh, backup is fine for me. Some will say, I just want to delete it. Some will say, I want to change the storage. I don't want to delete anything. Yeah.
I'll chime in real quick.
For now, I will put it into the not important edge case.
Yeah. Okay. Dan, go ahead.
Yeah, I was just going to say that I think that the storage is going to be something that people will want to customize. So that'll be something that will be very specific to the person that owns the station. So that might be something that we want to really think about making very adjustable. If somebody wants to hook up an external hard drive and have the capability of storing X number of hours or days, I think that that's probably something that somebody would, be very particular about. So, just something to think about.
It's also important to understand the kind of the mission, of Sky 360, right? Which we want to provide high quality data for scientists, right? So, and that means we are not going to record everything. We are only going to record what we detected. And that's what's important for scientists. They want to have done the event. They want to have all the data that happened a bit before, a bit after, and to analyze that, right? That's what we need to deliver, right? So all the rest is, yeah.
I totally agree. But I would say that in order to do that, that people need to own the stations and be happy with the stations that they own. And
Yes.
my guess is that people will want to have the ability to look at that video. And that'll be people will be particular about that element.
Look,
but I totally agree with you that that's a core, that's an essential piece. So that should be the priority. But my point is just that we need people to be very happy with that experience. And I think people will be particular about being able to store video.
So I mean, I'm sure Paul will have like the auto tweet of functionality of the station to his tweets. Paul, you here? Yeah.
Paul is here. Yeah. Yes, of course. It would be nice to have them automatically posting it somewhere. But I want to come back to the point. Every storage is limited. So later or earlier, I don't know how to say this, we come to the point where we say there has to either be disk storage be added or someone has to interact and delete. But let's say in most cases, at the beginning, if someone becomes a stationer and sets up a station at the beginning, they will certainly be working with their station and taking care of. But as I know humans and as I know myself, this attention curve falls down, okay? I'm not checking every day, I'm not checking every month, okay? I hope that my station is alerting me in time when it needs something to be done. And
yes, that's the goal, right? But when you're in development phases, you want to get that failure, so you address it.
Correct.
You don't address it before it happens.
You define it as a failure. I wouldn't define it as a failure. I would define
it's a system failure.
As a system design. No, it's a system design question. Because
it's a GitHub issue.
Yeah.
Thanks. It doesn't help. So if my station is up the mountain and then someone posts a GitHub issue, that doesn't help me. My point is that I think the question of storage and how to deal with it, the management, the philosophy with it, is system immanent, because we 100% come to the point where we have to ask, how shall we deal this?
Look, it reminds me the development of Windows, right?
Okay.
If you decided if you decided to deploy, what it was, Windows 95 or 98, with no firewalls, up alone in the mountains, right? Good luck. Back then there was no disk is full warnings, if I remember correctly. Definitely not in Windows 90. Definitely not in Windows 95, right? It only happened when they started to suffer for me. They started to address it and give the hey, you have 15% disk size alert and all of that, right? There is a lot to get into, like a production level product. I would not recommend to deploy the system in the mountain alone. Okay, if you don't,
this will be a quite normal use case, Ido. People will deploy the stations off grid somewhere.
Again, I completely understand. Okay, but we are too early in the stage to do that right now, unless you are comfortable with Linux tooling and messing with glue and all of that, right? No, I'm being serious. We have a lot to grow from to be able to say, hey, just buy it, assemble it, deploy it however you want, and the system will take care of itself. Okay.
It's an iterative process.
Yeah, it's gonna take time, but we will get there. I mean, we have enough knowledge and understanding to get there. It's about prioritization more than anything right now.
Okay, fair enough. You mentioned a word may I ask a question? Sorry. You mentioned the word caching 15 seconds before and after an event. How do you think we
Yes.
shall cache? In RAM?
Yes.
Ah, okay.
Yes.
Okay.
Yeah. So in a recorder, you have what is called like a storage level recorder and a transient recorder, right? So transient records, and if the system shuts down, it doesn't remember it. If it goes to storage, it does. Right? So RAM is fine for that.
Held in memory.
How much RAM does the Pi 5 have? The little Pi 5 have again?
There is 4 gigabytes, 8 gigabytes, and 16 gigabytes, and I believe there is also 32 gigabytes.
Yeah.
Right?
Okay.
We are
I
using the
believe most
16
of
at
us
the moment.
are using the 16. Yeah. So the 16 will have enough for 15 seconds.
Yeah.
Again, for the fisheye camera. It's not supposed to also be for the SDR and all of that. Each of them needs to have their own.
Yeah.
Right? Yeah, and then when the event is triggered, then the storage will say, "Hey, give me all of your cache, and I'll start dumping it to disk." Or we will find a different solution where the RAM exists in the storage, so we don't really need that on the sensor unit in a way.
You could use swap.
What do you mean swap?
In Linux, which is most likely what your Pis are going to be running on, you can partition part of your drive to have overflow for memory.
Oh yeah. But
swapping on SSDs is actually not that good
Yeah,
idea.
yes. Yeah, I understand that. Would it be possible to do a combination of mechanical and solid state?
Sure. So it's all depends on the data that you want to record. Okay. Bear in mind the fisheye camera is about almost 10 gigabits throughput. Okay. So if your mechanical drive doesn't do 10 gigabits, then you won't be able to.
Yeah.
Right. And that's where you
what if we
cache the entire system. Yeah.
What if there was a kind of like a stepping over from the solid state slowly into the mechanical, and then also solid state degradation can be avoided by avoiding erasures, and instead just kind of removing the references instead of actually trying to clear the power cells.
Not sure I follow. Sorry.
Okay. So one of the ways that operating systems mitigate solid state damage, instead of actually deleting the data off of the drive, it just removes the reference from the partition table.
Yes, unless you do trimming. Yes.
Right.
Mm-hmm. But how is it going to help me? Because if you're not doing trimming, you're actually going to suffer on the neck. And once the disk is full, and you need to rewrite, and because rewriting is not going to be like slower, because it will have to do the trim first, right?
Yeah. And plus, my suggestion kind of has the trickle charge kind of problem, where you have the battery, which would be your. Hold on a second. Be right back.
Okay.
Go ahead and continue. I'm sorry.
Okay.
Sorry, I didn't full capture that.
No, what he meant is I think what he meant is instead of overwriting or deleting by overwriting, we can only delete the file allocation table.
Yes. So okay.
But that's sort of quite low level stuff, right? I mean, I don't.
So
Sorry, I just want to jump in there. That's like really low level stuff, which I don't know. Like if you want to go to that level of, I mean, I don't think. I think that's GitHub issue territory. I really don't think we need to cover that sort of stuff at this point in time. That's
yeah.
like, yeah, goodness me.
So
That's quite low. Yeah, okay.
So this is exactly like what distracts us from focusing, okay? Because those are good discussions, but they need to be addressed when we actually face a failure, a system failure that needs to discuss them. So, you know, that's where like I'm really looking forward. Hopefully, like this week, I'll start to have more time on focusing on the GitHub and everything there. I sent something to Fabio, but I didn't hear a response from him. So I have some baseline that I want his input on. I'll try to get him this week to see where his head is at with it. And Mike, I'll share it with you if you have time, if you want to.
Yeah, no, it's fine, man. Yeah, sorry, I've been out of. Yeah, I've not been around recently, but yeah, I mean,
no worries.
I'm probably not going to be able to contribute anything in any sort of level of, you know, I'm not going to be able to contribute anything massively until maybe end of July, August, September sort of time. Okay, so just also to manage expectations.
Yeah, no problem.
So I just want to kind of keep abreast of developments. That's why I join the meetings, because otherwise I've got to catch up, you know, then and if there's questions, and I can try and answer and stuff.
Cool.
And we are going to send rain over to your place, Mike.
No sunshine,
okay.
so he gets finished quicker.
No, with sunshine, he's out in the garden having work.
We indoors now mainly, so yeah, so it's sort of not too much dependent on the weather at the moment.
Okay.
So
okay.
You can keep your rain, mate. We have enough of that stuff in winter anyway.
Thank you. I want to get rid of it. Okay.
Yeah.
Yeah. Okay. So let's go back to the core question. What for the lower version without recording? What components are still missing?
So I would say integrating the QHY into ROS2 and displaying everything that we saw today, you know, in OpenMCT. Right? That's what's important. And I will add also temperature, camera temperature.
Yeah, so that we can control
at least
cooling
to start.
Of the camera.
Yeah, I wouldn't say even control right now, just to monitor it. You know, and maybe have like a small stop in case it gets too hot or whatever. By the way, I got a bit confused with is the camera has cooling or that's heating?
Cooling.
Because okay. Because my you know, with telescope that I work with, most of the time is about heating, because it creates like a fog.
Cooling only.
I'm sorry.
Cooling only.
Okay. Yeah. Okay.
So you said
we will need to take care of like there will be some fogginess that happens. I spoke with Christian about it like a long time ago. I need to speak with him about it.
So what you are talking about is the internal climate of the enclosure, because the camera is housed inside, and when there is the temperature over the dew point, then we have condensation on the outside if it's cold outside. So we have to get rid of the humidity inside. That's a totally different topic, and we are 1 year ago we were addressing the topic, and we postponed it because we have more issues, more urgent issues than this one. But yes, that's part of the enclosure. Actually, is a service of the enclosure for itself to keep the climate in control.
Yeah. So I would say again, for all of this, we can box it as another robotic part.
Yeah.
For the health of the station.
Yeah, exactly.
Of the enclosure.
Yeah.
Yeah. So everything will be an open MCT, and we can see everything. So
if I may come back to what I asked, what components are missing, you said two major things. One is to control the camera, and the other thing is the OpenMCT user interface.
Yes.
May I ask about the control of the camera? So for now, we use the driver of the camera as it is, developed by QHY, right? The standard driver, basically.
Yeah.
Do we need to expose that via ROS2 in order to change parameters and so forth? Okay, this is not done yet. This is just directly done in algorithms that Fabio did. He just has to extract this and make ROS nodes out of it.
You just need to break it apart into ROS2 nodes.
I see.
Exactly.
Okay, so basically algorithms and functions are already there. It just has to be wrapped into ROS nodes.
Yes.
Got it. Okay. But the big thing that is still missing is the OpenMCT part.
Yes, but first of all, we just learned about it, so I think there was a curve there. Second of all, there is no data yet, so what to display?
Yeah.
And to actually integrate it into OpenMCT, as long as it's functioning ROS node, that's relatively easy to do. So to actually getting it into a ROS node that is able to, if you're able to interact with it, especially if it's publishing a topic that you can subscribe to, or if there's a service that you can interact with, you can use the library, the roslib.js library to interact with it. So it doesn't even really, we don't actually need to even be using OpenMCT. It's just really interacting with it in a web page. And we're just putting that web page in OpenMCT.
Yeah. No. I'm going to say something.
Doing that is, executing on that is relatively, the harder part is just getting it into a functional ROS2 node.
Yeah. So I'm going to say something. Okay. I'm going to shoot myself in the leg saying that, but I hope it's going to be a good exercise for everyone to understand what I'm trying to emphasize. Okay. And the moment we have this lower version working, it's going to crash probably within several minutes. Okay. If not sooner. The reason is the raw image is so large, and probably the network between the browser and the Pi will not be able to play back normally the video, which means we will need to do video compression, okay, to show and not like delivering raw images, okay. But I will say, do not work on a node that does the video compression. Let's wait for it. Let's experience it, get like evidence, and then open an issue and discuss it under an issue. It's a better work.
I think that's already being done. The compression.
No, there is a raw compression on the image, but not video compression.
There is video compression, as far as I know.
We're processing them as images. So there's raw images and compressed images as well.
So basically, there are images, but I can recall.
You have the two topics: raw image and you have compressed image. Yes. And the OpenMCT is going to listen to the raw images, to the compressed images topic.
Correct.
Yes, and what I'm saying is the video side, the video or the image that you have, okay, you're wasting a lot of bandwidth, okay, and even with compressed image, it's still going to be large. The image is still going to be big, okay, and you will have a failure point there, 100%, okay.
Wouldn't you resize wouldn't you just resize the images, because it's pointless
Yeah.
sending
So
like
again,
such
you
a
can
mass.
do all of that. That's what I said. I'm going to shoot myself in the leg.
Okay.
So I'm opening that.
Okay.
Yeah, but I'd like to have all of this discussion. One, we hit that failure under GitHub issues, and then discuss it like right there what we want to do. Because yeah, we can change the image size. We can create a lossless video stream, okay, with a better size. We can actually allow for investigation to move frame by frame. So now you get the full frame, right? There is a lot to unpack here of how we want the operational mode of that to be, right?
May I?
Yeah.
May I ask a question here? Because we're talking about something very specific of the user interface functionality. Because we want to see something that can zoom in, zoom out, and pan and view the view. Wouldn't it make sense? Is it performant enough if there's a ROS node taking one image and on the request of the user interface delivering a cropped version of that image? Would that be performance-wise speedy enough to make it fluid playback? Because the data will be smaller when it's cropped, you know. For example, if I'm on zoom level 101, I'm zoomed in so that 1 pixel of reality matches 1 pixel on my desktop, on my screen, for example. I do not need all the rest outside my view. So if there's a ROS node delivering this, that could be very performant, I think. The question is the ROS node performance enough to create that?
So it might be okay to trim the size for like visualization and stuff, but you cannot touch it from the storage. So the storage has to have the full frame.
Yeah.
Because again, for scientific analysis, you have to have all the data that you can have, given you had an event, right?
Of course.
If you didn't have an event, I don't care about the data that much. But if you detected something, all the data that is around that detection, I want to have it.
Absolutely.
Okay. But yeah, this is exactly the discussion I want to have. Like once we have that, and so we can
then optimize.
Focus on optimizing. Exactly.
Got it.
Mm-hmm. Right. Get it barely working and then optimize.
I get it.
Barely working and optimize. Yeah.
I get it.
Can I ask a question quickly, man? So I did implement a recorder using ROSBag, the ROSBag stuff. Okay, so I just sort of wanted to make you aware that there is that is there. Okay, I know I've done a terrible job at documenting and all this sort of stuff, but there is a node that does record, and currently it uses ROSBag. Okay, just so that you are aware.
Yes.
Okay. So
I remember
just
that.
a question about that. When it saves it, so it uses ROSBag to record that. How do you play? Is there a mechanism to currently play that back, or do we need to build something to convert that into something that we can play back?
Okay, so I can probably help with that a little bit. So what happens is so I'm just trying to figure out how to just articulate. So the ROSBag will record topics, and then when you play back, there is a command line command to play back a database. So basically, a track or a event are recorded as individual little databases, and you play back the database as a whole. And what it does internally, it broadcasts to those topics Does that make sense? So it's not, so you don't have to interpret the playback and publish to a topic. The process of playing back publishes to a topic. So when you're sort of in playback mode, you would not have many.
I was just going to say, is there some type of, I guess, is it publishing the original timestamp? Is that how you know that it's it's a recorded?
Yeah. So it plays back. It publishes the message in its entirety. Mm-hmm. So if you record, I think currently we capture 5 topics worth of data when an event is being recorded. If you play back, it plays back all 5 topics as well, and it plays back the entire message, including the header. So you essentially you only have to run a very small number of nodes, and you will get the same user experience. In a way, like if you, I'm just trying to, that came out wrong. That wasn't articulated correct. So if in playback mode, you would not have the recording nodes or the capturing nodes running. You would have the playback node running, and then I think it's the annotated frame provider. Yeah. So the annotated frame provider node, because that captures all those events, and then the visualizer, which displays the annotated frame. So you don't have to have any of the other stuff running. It is actually quite cool once you get your head around it. You know what I mean? And with launch files also, So if you want to go through that, Dan, I can give you a demo. I got to kind of brush up on it as well, but it's always easier to see it in sort of action.
Yeah, definitely. Well, that helps. Thank you so much. Great. And yeah, that helps. Another, I guess, question or comment. I think whether we're watching video through the user interface that is effectively real time, what we can do with that versus watching video that is, or talking about the experience of watching historical video. I know we're talking. I know we just had the conversation about recording, but those are going to be very kind of different experiences. And the reason I say that is that what's happening in real time, or if we have the ability to, if it's already been recorded, what we're able to, like the performance issues can be mitigated, by whether it's buffering or pulling from a.
But bear in mind one thing. Okay, I'll go deep in that also. I'll reiterate on that. When you're in playback, you're causing more performance strains on the system. Why? Because real time is always running. Okay, you might be in playback for the user, but the system is still trying to detect everything live. It doesn't stop, right?
That makes sense.
Right.
That makes sense.
Now, you're right. In these mission control systems, you have 3 modes. There is configuration mode or setup, right? When you set up, let's say, your geographic coordinates, the station name, whatever, right? Sensors, if you add like additional sensor that you added. Then there is running mode, right? Well, that's like the real time, right? And then there is investigation mode when there is an event, you're looking at an event and you're trying to analyze it, right? And you're right, when you're analyzing something, the scientist has different UI to look at, right? He has far more tools than the normal like fun stuff that you see in like the real time, right? Because he's able to pause, he's able to look deeper, and he probably wants to run a bunch of like
filters,
filters, algorithms, whatever, to understand and do like proper analysis, right? Something that you won't be able to do on kind of live mode, I would say.
And that is not necessarily real time. Analysis is not necessarily real time.
And even if we're watching, I guess, even if we're watching something in real time, if we're not controlling anything, then it's possible that we could have a lag and have it be acceptable. So we could have a client-side buffer.
Yeah. So
on the web, on the browser side, to increase performance. So, if, for example, we're not needing to control a secondary camera as a result of what we're seeing manually, and need to do that in real time.
So two things here. First of all, timing is very important to the station. Okay. And that's like the main reason that we moved like to ROS2 and DDS, because it allows us to have like deadlines and timing guarantees, right? So we can do synchronization across multiple sensors and all of that. If we have latencies on the UI, that should not impact the real time of the system whatsoever. However, the real-time aspect of the OpenMCT itself should be aware of the time constraints, and OpenMCT already does that. So if you have latency issues, OpenMCT should have a way of alerting you on stalling data or stuff like that. Okay? I don't know if you read about the timing aspect in OpenMCT. And playback and all of that, because I'm sure there are documentation around that.
I can definitely look into it, deeper. I guess my point is just conceptually we can increase the performance of viewing video client side, no matter how large the image is, if we don't need to see it in real time. That was kind of my point. If you were saying that we may have a large issue with the image size, we don't have, as long as we're not immediately deleting that image.
Then I will tell you, then don't show the video at all. Right? And then only show it on analysis mode. And just show me the situational awareness of, where you think the object is and all the tracking object and stuff like that, right? But yeah, I get that. It's an optimization. I would say like dump it there, put everything, and then we'll do like optimization.
And it's currently working with the compressed image. So.
Yeah, so that's fine. The compressed image, like, look, in reality, we don't want the raw images, like really. The only reason that topic exists is because that's what we get from the camera, and we publish it immediately, and then it's getting compressed immediately. So everything else after that is going to use the compressed image. Even the recorder is going to store the compressed image.
Sorry, I was just going to ask a question. So, if you captured an event and you wanted to do like serious analysis on it, would you use something like OpenMCT or like a tool that we had provided to do that, or would you just expect to be able to have that recording as a package that can be that can be verified and interrogated by, I don't know, specialists, if you like, and you as an end user are able to take a dump of get a video file which is full size, and you can then use that to interrogate with other sorts of tools, because I think it's quite a specialist sort of topic, and I don't know if it's really worth trying to reinvent the wheel with that sort of stuff. Is the point I'm trying to make, I suppose.
Yeah, no, I look, analysis, there will be I would say basic level of analysis. Let's say, maybe looking at the video, I want to be able to pause it and go back a bit and zoom in and I don't know, take a snapshot or whatever. And there will be a proper scientist looking at the data. Pretty sure it will be different tools.
Yeah.
But if I look at the tools of what available, I think OpenMCT, can give us the foundation of what I need as a user, and I think ROS2 and all of his ecosystem can give the scientists what they need, right? Because everything is based on ROS2 and topics, right? So they will be able to hook up all the simulations and analysis and notebooks that they want into the ROS2 and analyze everything.
So that focuses on a point in time where we are right now. There are some organizations like the SCU working with data gathered from several systems. And the point is that there's no standard yet. So this data generation is not standardized. So some collect video data, multiple videos. Some collect more sensitive sensors like, I don't know, temperature, whatever, barometer, stuff like that. So there's no software where you can feed one package in and everything is there. That software needs much more to be flexible over different projects, let's say. But there is no such software yet. So everyone is working with Excel and, I don't know, PowerPoint to create their outputs. And that's why we are at a point in time where I think, for myself, it's like one of these days where new technology becomes available to the market and people not even having the software yet to process that. It will become true. Either someone else does it, or we have to do it. At the moment, I see ourselves have to do it because I don't see anywhere any activity towards that direction. Galileo project is doing their own stuff. They are not analyzing anything else outside Galileo. I mean, they do historic data, what they told us now, but it's about the data they create with their systems. So they will analyze their systems and it will be a software for their systems. The question is, if we create data for more or less every scientist on the planet, we should do it on a platform that is flexible and has a lot of tools like, I don't know, Grafana, Keras, statistical tools are implemented, whatever. A kind of a cloud service that has all these features enabled.
Yeah, I mean, here I'm not familiar with how a scientist does analysis on such data, but whatever tools he wants, I will make sure that I can export to him.
Yeah, I think it's probably a bit too much detail. I guess I think the main thing is as long as we capture what eventually will be required, I suppose, and then I would say let's start with again the Aloha without recorder or and again it's okay to put the ROS bag that you worked on. Okay, it's fine. But when we speak about with the recorder, we need to be more focused on that. It's not as straightforward as you know, Mike. No, that's fine. Yeah. No, I just wanted to. So I just thought I'd mention that, right? Because I I just wanted you guys to know that there is an example of a Rosberg recorder. That was pretty much it. I know it's not that simple. So no, I get it, mate. So yeah.
Okay. And you know me, I want it all embedded. I want the Boyan to have like a
I know you, and that's
motherboard. I want
yeah,
all
that's
of it embedded.
And I want
that's
it
why I'm trying to
tomorrow.
just pull you back down to earth as well. And Richard wants it all,
Tomorrow.
scientifically and statistically perfect yesterday, and it doesn't work like that, really.
Yeah, but
Yeah.
So yeah,
it needs people like
I was just
us.
trying to tether you guys to reality, basically.
So okay.
Oh, wait after this recorder is stop. I'll tell you something.
I want to have one question
About
on
reality.
record. So before we stop recording, I have one question I want to have on record. So from the components that are still needed, you mentioned, of course, the OpenMCT part, which is in little parts and tests, existing in tests, and the camera to become a ROS2 node. But I think there's also the GPS and the timing issue that we have to solve sooner or later. Better sooner than later. So my question is, if the only component that is needed is a GPS dongle that has to read out in, let's say, in a per second way and creates a ROS2 node to deliver the time to the local NTP service, for example, or I mean, it's even shorter that the local NTP can configure to use the mouse as a NEMA, no, there's a standard for it, device, so that the NTP is automatically synced with the GPS time. So it doesn't need to be a ROS2 node time exposure, but I don't know. But the second thing is the coordinate. The GPS gives you the local coordinate. So we need to have a ROS2 node that is creating that stuff. And this is pretty easy to do, I think, because the GPS dongle is there, the driver is there.
So a few things. Okay, the GPS dongle will not give you accurate GPS location. Okay, it has a wrong of about 10-15 meters, if I remember correctly.
Of course.
In a good day.
Yeah.
Right? But I wrote a ROS2 node that already put all this GPS data into a topic. So that shouldn't be a problem to create it. But yeah,
but in this case, someone has to enter the geo coordinate.
No. It read it from the COM, the serial port, and write it to ROS2 topic.
So this geo coordinate from a GPS node is already existing.
I wrote it like several months ago. I don't know. I didn't commit it anywhere. I wrote it as a sample because I couldn't test anything back then.
Okay.
But it shouldn't be too difficult to write. That's yeah. But I wouldn't say that a showstopper for Aloha because that can be. I want to make sure more that the camera is operational, healthy.
Yeah.
More about the configuration and all of that. That can come later.
Yeah, okay.
But that's fine. It's not a big task.
I get your point from your point of view. But there, for example, Dan, sorry, Dan, maybe I say something totally wrong, but let's say Dan could be someone who helps on OpenMCT or just creates this little GPS ROS2 node.
Oh, yeah.
Something like that.
Yeah, that's fine.
Not everything has to be done by you. So there are a lot of people who want to help. So I think we should ask them. And for example, Aaron, are you still with us? Aaron, Mr. Silverman. Okay,
I'm here. Mute myself. I've been listening. Yeah, I mean, I haven't been available to do what I promised I would with the onboarding stuff, but I think I'm in a position where I can start to look at that and start to create documentation and kind of an overarching system in which people can try to pick a team and join in. I think it would be helpful for more people to join up.
Cool.
At least to start, and then to eventually work on the simple tracker.
Yeah, we have to get rid of that name.
Man.
We already get. Yeah, I knew it. Yeah, don't worry.
Yeah.
The moment I'll rearrange GitHub, there will not be a simple tracker there whatsoever.
No, that's fine. No, of course. I was going to do it a while ago as well, man. So it's not all on you. But yeah, one of the things that one question I had is to do with like is to do with GPS location and the sensitivity behind that as well, because obviously that you're giving away people's sort of location or station location, which will be associated with potentially with a person, and capturing video and all this sort of stuff. Has anyone potentially looked into that? And is there any gotchas there? Because I also suspect that that's managed or it's controlled quite differently across countries, and all this sort of stuff. Is that is it okay to capture that sort of info and stuff?
So right now, because the station are not designed to be connected anywhere, it's fine. And they are not sharing information. You need to physically share it, right? But yeah, you're right. The moment that it's going to be connected and online, then you're going to get into compliance concerns around privacy and stuff.
Yeah.
But here is the thing. I'm starting to think more and more that the station can be classified as an advanced weather station, or with the foundation of a weather station, which is okay, right? And by the way, if you guys didn't see it, I was surprised to see that the weather station protocol allows that actually in the protocol it has a place to report moving objects in the sky.
Okay.
So I was like, this is cool. On very low frequency, I think like 400 hertz or megahertz or something. Yeah. Cool. Hey, okay. Fabio.
Hey, Fabio's there.
Hey, guys.
Hi. So yes, these are basically the two things that are still missing. It's the camera's 2-node, and let's say I see it as system critical to have a GPS time and coordinate. You don't see it as system critical, but it's a small thingy, and it can be easily added.
I do see it as system critical. I just don't think it's critical for Aloha.
Okay.
Okay, because when do you need the GPS and the timing? Where will you really need it?
Yeah, the timing is a basic thing. You always need it to have data that is correct
but for now, it's not that we don't have time. Now it's going to use system time, and because you only have one compute, right? You don't even need an NTP server, right? You synchronize it on time, and that's it.
Yeah,
right.
True.
So the worst case, your entire station is like 2 seconds lag or 3 second lag, whatever. Which even 2 seconds, it's probably too much.
We cannot correlate anyways. Right? So got it.
Yeah. So it's good enough to where we are.
Yeah.
It's not going to be good when we are going to have the telescope in, and now we need to coordinate timing across multiple computes. Then it's going to be a problem.
Yeah.
Then it's going to be critical. Right?
All right. Okay. Got it.
Yeah.
All right. Yo, I've got all my questions. Any more questions? Or shall we give Fabio the word? If Fabio, you want to add something today?
No, in fact, not. This week was a little bit hard on me, so I didn't have much time to do much. I was trying to do the ROS2 node for the camera, and but I couldn't yet. Yeah, I couldn't yet. But
Well,
if
you want to work on it together this week, I'm available for that.
Yeah, that's perfectly fine. That's okay. We can do that because I was planning to make a quick one using Python because I exported all the KHY interface to Python also, so it's pretty easy just to get what we have and instead of calling the OpenCV camera, we call the KHY camera. It's as easy as this, and then I'll just to make it work. And then I will create another node and do everything that's properly in the proper way. So I will be exposing all the parameters together with the image, like the exposure time, the gain, and everything that you have on the camera. I'll be exposing together with the image.
Yeah, and we think I like it.
yeah, I'll be exposing the image and also the metadata of the image. So all the data we have from the camera.
And if you create also, I think a service to, and I can help out too. But if you create a service that we can interact with, we can create a UI element to.
Yeah, the Rust2 node will also get receive the parameters to adjust. So I will be exposing parameters for us to adjust, and I can and so we can change it from the interface also.
Okay.
We'll be able to adjust exposure, gain, and everything by the Rust2 configuration node. So, but right now I'll just start with a plain implementation of the camera, just getting the image and sending on the pipeline, and that's pretty easy to do. I didn't have much time to do it this week, but I will do it for next week. Just a simple implementation, and then start working on the real Rust2 node.
Cool.
Yeah. By the way, Dan, just so you know, OpenMCT has its internal recorder storage, which uses the browser cache, browser database.
Local storage?
The local storage, yeah, exactly. So I think that's on by default. So automatically what is being displayed, it's being recorded.
Okay.
But I'm not 100% sure. I remember reading about it. No.
Yeah, I think if you're using, depending on what kind of plugin you're using, it may be saving it into that. It's saving your kind of the structure of your data, but you can definitely store it into that through OpenMCT.
Yeah.
Okay, guys. It's almost 2 hours now. If there's not any more topic you want to raise for today? Okay. Yeah, I would say, Fabio?
No, sure.
Okay.
Let's do it.
Okay.
So sorry for not connecting before, but this week it's a little bit hard.
Okay, got it. But wanted to say is if there's not more topics for today, I would stop recording now. Okay?
Okay.